Hello everyone, it's Jason Kelly right here. Now, I've gone and downloaded this new app on the Play Store from Android, and it's called, I'll tell you so you can download it, INKredible, like this, and this part's in lowercase and that's in uppercase. And it's kind of just occurred to me that it's probably a play on the word incredible, but this is called INKredible. So it's quite clever after all. I just thought for a minute that maybe it was a stupid name, but actually it turns out to be quite good. But I'm going to have a little go actually, because I think one of the interesting things that perhaps I could do with my channel is actually demonstrate some mathematical methods that are pretty useful for when using them. And an example would actually be such as, not only, like say for example, you take a bracket, so let's say example 1, and it writes really well. At the moment, you've got different pens, so you can choose fountain, calligraphy pen, wet brush, ballpoint pen, or no ink effect. I like the fountain pen for writing math sort of related stuff, and I think a thickness of 6 is pretty good. And I have it on a black background with white ink. I think that looks the prettiest. And to rub out, I can just hold down on my little S Pen button. So let's say, for example, we have the bracket 2x minus 3, and we're going to times that by x plus 5. So quite clearly we'll just do that by first doing times under 2x by the x, so that's going to give us 2x squared. Then we'll do these ones here, so that's going to give us 10x plus 10x. Then we do these ones, which is minus 3x, and then we do the outside brackets here, and that's going to give us minus 15. And then we can tidy it up in the middle because they're like, oh shit, did not know that could do that. So we're going to then tidy it up in the middle by combining the like terms. So we get 2x squared plus 7x negative, minus 15. So that's all well and good. But what about when we're expanding? How do we go from, what about when we're factorising? We start with this in its factorised form, this equation here, and we expanded it. But how do we work backwards? What's a good method for actually going from this to this? Well, I've got a method for that. That's one I've always enjoyed, and it goes something like this. So first of all, you copy the first term down. So you go 2x squared, and what you essentially want to do is you want to first multiply this term here. This is, by the way, just for reference, any quadratic equation like we're dealing with comes in a form like this: plus bx plus c. So this is the coefficient of the x squared term, that's a. B is the coefficient of the x term here, and then c is just a constant. So if we combine that, we can see that in this case above, we've got 2 as the coefficient of x squared, we've got the coefficient of x is 7, and then the constant is minus 15. And also always pay attention to the sign, so let's just get rid of a bit of that there, and wipe all that off. So, as I was saying, how do we go? Right, so we first copy 2x squared. Then what we want to do, we want to multiply these two terms together, the x squared coefficient with the constant, and remember that's negative, so we get minus 30. Now it's minus 30, so whatever we're dealing with, they're going to be two different signs, right? And that's important to note. Minus 30, we want to try and think of two numbers that multiply to give minus 30 that also plus or minus, so you can add them together, whether you're taking one away from the other one or just adding them. You're going to end up with 7, right? So we're dealing with minus 30. So think of some factors for negative 30. So you can, one just comes to mind, 10 and 3. So you could have positive 10 and negative 3. That 10 is going to have the 3 subtracted from it, and that's going to give us 7. So watch this. We're going to say plus 10x, and remember these are the x ones, so bear that in mind, don't forget the x, minus 3x minus 15, right? Scroll up a bit. Then what we want to do, we want to factorize each of these parts here. So I'll show you how we do that. We're going to first treat them separately, so let's deal with this one first. You can take an x term out, and you can also you have to find a factor of 2 and 10. Well, the highest common factor, we call it, of 2 and 10 is quite clearly 2. So we can take 2x out of this, divide 2x by 2x squared, you're going to be left with x, divide 10x by 2x, and you're going to have plus 5. Okay, now remember when we're dealing with this one, when we're dealing with this one, we have to remember that there's -1. In fact, I can just use my pointer. I don't have to always draw on it. So we have negative terms here. So we take, at the very least, we're going to take a negative number out. But the highest common factor of these two terms here would be -3, right? You can't take an x out because there's a constant here, hasn't got an x term there, so it won't work. But we can take -3 out, so we put -3, okay, and we're going to then divide -3x, divide by -3, where dividing a minus by a minus is going to give a positive answer, so we're just going to have x, right? And -15 divided by -3, again, going to give positive, so it's going to be +5. And this is the part where you know whether you've gone wrong or not, because if you've done it right, these will always match, right? The parts that have been factorized out will always match. If, sorry, that's just where, oh, shit. These parts will always match in the bracket. What's in the brackets will always match. Now, if they don't match, check your method or check whether you've made error, say a sign error, a number error, a miscalculation of the number, arithmetic error. Check that. So then what we do, we then realize that what we have here, these in the brackets, can also be factored out again. You essentially have 2x minus 3 that's been times through by x plus 5. So we can also rewrite this like this. We can go 2x minus 3, and that's being multiplied by x plus 5. Okay? And so this is the part where you can confirm whether you've gone right, and then you scroll back up to what you had originally. So we had 2x minus 3, x plus 5. So as you see, we've managed to work backwards to get it factorized again. And also, incidentally, I want to also show us, I might as well just show you also how you can actually determine the roots of the equation. So first of all, you want to put it equal to 0, because the roots are what actually are the points in which the curve, this is quadratic, so it's called a parabola. That's the point in which this parabola will be intersecting the x-axis. Now, when it intersects the x-axis, it means that the equation is equal to y is equal to 0, right? So you've gone no dimension, you've gone up or down by no dimension, right? So we're just working on the x-axis. So we equate it to 0, and then we solve backwards. Now, we bear this in mind. We say that so I was just trying to articulate this in my mind, so it's going to be clear. Now, what we have to bear in mind, right, is that we want to try and make at least one of these brackets 0, because 0 times by any number, no matter what it is, you can times 0 by infinity, and it's still going to give 0, times by negative infinity, and you're still going to get 0. And that's what we're aiming for. And we can do this actually by essentially solving these individually, solving these brackets on their own by equating each bracket to 0. And what we're trying to do, we're trying to find the inverse of x to what function you're applying to it, because that way they're going to cancel each other out. So it's quite obvious with this one that if you had -5 plus 5, you're going to get those two numbers cancel themselves out, which means that -5 is already a root that we can work with. It'll be -5, 0. That's a coordinate. That's the point in which one of the x-axis is intercepted. But this one will be a little tricky. It might be as obvious, and I can show you the algebraic form of solving it. But I'll first go over the algebraic form first with this one here. So let's say, for example, we take x plus 5 and we equate it to 0, because we want to make it 0. So we have to solve for x so that it then equals 0. Well, here we can take 5 from both sides, so quite clearly that's going to be x is -5. Now let's do the next one here. So we have 2x minus 3 equals 0. Again, this is just solving for x. So we have 2x equals 3. Then we can divide by the way, I've done that because you can see negative 3 on this side. So to reverse that, we have to plus 3. And then we have 2x here. Now we can just divide both sides through by 2 to get x on its own, and then that's going to be x equals 3 halves, which is 1.5. And so essentially we found the two coordinates and we can write them down. And this is the symbol for therefore in maths. It's a very useful symbol. In maths, mathematicians are quite lazy. We're not English orientated really. We like things to be as shorthand as possible. So we have all these symbols that save us from writing things out all the time. And so we'll have the two coordinates would be minus 5, 0, and we'll put 1.5, 0. And so if you had it on like a little graph here, you'd have 1.5 there, and you'd have, say, all the way over there, something like -5, and then there'll be a point in which it's intercepted here. That's another thing I should actually show you. I'll show you how you find out where it intercepts the y-axis. Now it intercepts the y-axis when x equals 0. So let's scroll back up here. We can use this original equation here, this one. No, the original one here. So this is the expanded form. Now, if we say, well, what happens to y when x equals 0? Because remember, we're looking for the point at which it intercepts the y-axis, and that's when x is going to be 0. It's where you've gone horizontally to no degree at all. You've stayed where you are at the origin. Now, as you can see, 2x squared is just going to times, that's 0 squared, which is just going to be 0. 0 times 2 is going to be 0, plus 7 times 0. Basically, it's always what the constant is. That's the shortcut, but the reason why is because here the coefficients are being multiplied, and you multiply anything by 0, no matter how many times you square, cube, or even bring it to the power 4th, it's always going to give 0. So the constant is the limiting factor, and here we can see it's minus 15. So if we go back to our little graph there, we're going to need a lot of space to actually draw this thing. So let's say somewhere down here we've got negative 15. We've got negative 15 here. That's negative. That's where it's going to go. And to draw a little parabola, we just want to try and get it through those points. Just do it loosely. So there we go. This is the equation of y equals, and normally I don't like writing these things out, so I just redefine it as f of x. It's a function of x, and that would refer back previously to what we had. So there you go. That's a quick way of actually doing that. It's pretty neat if you ask me.